this equation? It looks like we have two b terms here and a b term here, so we should simplify this side because we can simplify the expression on this side. So we collect like terms. Negative 7b plus 5b is negative 2b plus 1 is equal to negative 3b plus 6. Alright. Now if we want all the b terms to one side, how could we zero out minus 3b with a plus 3b and a plus 3b on this side? Okay, 3b plus 3b. Don't really need to show that plus on this side, do you? Okay. Now that zeroes out the b's on this side, and over here 3b minus 2b leaves us 1b. I won't write the 1. Bring down your plus 1, and on this side all we have left is 6. Now we can use the addition principle again to subtract 1 from both sides. That's the same thing as adding a negative 1 or subtracting 1. That zeroes out all but the b on this side. And subtracting here gives us 5. And remember that this is a good solution if when you take it back to the original, it checks. Okay. Okay, this one has a little more work. This is the first time we've seen parentheses. Okay, so we need to clear these parentheses. Alright, this expression on the left has the parentheses. So how do we do that? We're going to distribute because we can't do the work inside. We have a variable, can't add the unlike terms. 6 times x for 6x. 6 times 5 plus 30 equal 4x plus 23. So we have x terms on both sides. If we want to zero out this 4x, that would take minus 4x, which is the same thing as plus negative 4x on this side. So this side zeroes out, and on this side we have negative 4x plus 6x for 2x. Bring down the plus 30, bring the equal sign down, and on this side all we have left is 23. Now we want to isolate the variable term, so we want to subtract 30 from both sides. So subtract 30, which is the same thing as plus negative 30. So this zeroes out here, and we have 2x is equal to 23 minus 30 is negative 7. Now we're left just to divide by 2, and that gives us x is equal to negative 7 over 2. Now that's a negative fraction. It's an improper fraction. It is simplified, and if you divide it, you don't get an integer, you get a decimal number. So remember that this is a good form of the answer. Since it's not a repeating decimal, then you might get credit for a decimal answer as well, as long as the sign is correct. Let's take a look at this one. We have 3x plus 17 minus 6x. We could go ahead and simplify here. Remember, this is an equation, so we want to simplify each side. So 3x minus 6x here. And over here we have like terms as well, don't we? So let's just simplify what we can. This gives us negative 3x plus 17. This side gives us, let's see, 17, and this gives us negative 3x. Now if we want to zero out the x's, since we have them on both sides, zero out the x's on one side, let's do plus 3x, and that's plus 3x. Now that zeroes out the x's here, and amazingly, it zeroes out the x's here as well. So 0 plus 17 is 17, and 17 minus 0, or plus 0 here, is 17. Now remember, this is an unusual case where we're trying to isolate the variable term on one side and we end up with no variable term. So what we have is a true statement. We have a true equation here because 17 equals 17 is true. Because it is true, remember, we call that an identity. And because the result is an identity, we know that all real numbers is the solution set here. Okay? It's not just one number that works, it's all real numbers work. And if you want to prove it, just pick a few and try, and you will see that all real numbers will check true. Let's take a look at this one. Negative 17 plus x and x plus 14. If we want x's on one side, then how would we zero out this one? X would take a minus x, which is the same thing as plus a negative x. That zeroes out the x's here. Negative x plus x, well, it zeroes them out here as well, doesn't it? And we have negative 17 is equal to 14. Now this is similar to the one we just looked at because we were trying to isolate the variable term and it went away, but we don't have a true statement here. We have a false statement. Negative 17 equal 14 is not a true statement. It is a contradiction. It's false. We call it a contradiction. And because we have a contradiction for our result, we say there is no solution. There is no real number that will check true.